In the last lecture, we have seen some more examples based on the statistical techniques, and we have seen the examples of correlation of coefficient of correlation. Precisely, the Carl Pearson's coefficient of correlation. Now we'll see some more examples based on this. So let's have some more examples based on this. Okay. So here, we'll see some more examples. Okay. So let's have the examples. So we have the example here. I hope you are able to see this. Okay. So we have to find the coefficient of correlation between x and y from the following data. Okay. So this is going to be our example 3. Okay. So we go with the solution. So what we have here. I hope you are able to see this example. Okay, so let's have the solution for this. Okay. So let R be the coefficient of correlation between X and Y. Okay. So we have what we have, R is equal to summation xy upon square root of summation x square into square root of summation y square. Okay, let this equation 1, where this small x is x minus x bar, is mean deviation of x from x bar. Small y is equal to y minus y bar, is mean deviation of y from y bar. Okay, what is x bar here? So we have x bar is equal to summation x upon n. What is y bar? Y bar is summation y upon n. And we have n is equal to, what will be having? Number of observations. Okay, so that's what given to us. And what we have here, n is equal to, what is the value of n we have? What is the value of n we get here? So we have 6 observations, and hence we have n is equal to 6 here. Okay, and now we consider the following table. Okay, so let us consider the following table. So what table we'll have here? Okay, so we have the table capital X, capital Y, then we have small x, x minus x bar, then we have small y, y minus y bar, then we have x into y, we have x square, and we have y square. Okay, so these are the columns of the table we need to have. Then we write all the observations of x and y, and then we have to calculate this table. So where we are interested in the summation x, summation y. So we are interested in summation x, summation y. We are not interested in summation of small x and small y. Here we are interested in what is the sum of small x y, x into y. What is the sum of small x square and small y square? Okay. So here we have to write this all data. Okay. So prepare the table. So we have the given data here. So we have to prepare the table. So please prepare the table and tell me what is the value you are getting. What is the value of summation x you have and summation y you have? So after calculating these two values, we can write here. Okay, from the above table, we have x bar is equal to summation x upon n, and that's what will be summation divided by 6. Summation y bar is equal to summation y upon n, and that's what we have this by 6. So I hope you got the summation x. Have you got the summation x? Anyone of you got the summation value? Summation x is 36 and y is 60. Okay, that's good. So what we get here, this is going to be this we got, and this we got. This is going to be 36 and this is 60. So we got 36 and here 60. So this is going to be 6 and this is going to be 10. So we got x bar is equal to 6 and we got y bar is equal to 10. Okay. So now use this value x bar is equal to 6 and y bar is equal to 10 and compute this table. Okay, so calculate this table. So have you got the values? Good. Okay. So you got the value of xy, you got the value of x square and then y square. Okay. So let us check your table whether you got the same or not. So please check these values. Okay. So we are interested in these values xy, x square is equal to and then summation y square and summation x square. So once you are able to get these values, we are able to write from equation 1. So we can write from equation 1 we have. So what we have here, see, the R is given as summation xy upon square root of summation x square into square root of summation y square. Okay, and then we have all these values here now. So this is going to be minus 21 upon. So you have square root of 36 into square root of 242. So give me this value. What value you are getting for R? So you are getting the value for R is minus 0.2647. Okay. So you got a value minus 0.2647. Okay, and hence what we can say is here, so we get R is equal to minus 0.2647. So you got the value here, we can say is the coefficient of correlation between X and Y. So that's what we have. And now I hope all of you have got this value. So do you have any doubt in this example? Yeah, that's a good question. Okay, so why summation small y and small x is always equal to 0? Because they are mean deviations. Okay, so small x is the mean deviation and small y is the mean deviation of x and y respectively. Okay, so the sum of this is the theorem in statistics. The sum of the mean deviations equal to always 0. So this can be a project question. Okay, so prove that the sum of the mean deviation for any variable is going to be 0. Okay, so this is the theorem. You can prove this. Okay, so this is the theorem that the sum is always going to be 0. So if you choose the assumed mean method, okay, you assume any mean and then find out, then the sum will not be 0. Okay, but we are using actual mean. Okay, so when you use actual mean, then you don't have any problem. But when you do not use actual mean, then definitely the sum is not going to be 0. So in the coming examples, we will see that also. That's good. Okay, so let us go for the another example. Okay, so we try. We'll see the another example here. So let's have this example. So up to yet, we have seen that the data given to us was the raw data. Okay, so when you have directly observations given, so here you can see in this example, directly observations are given. Okay, so when directly observations are given, then this is called raw data. Okay, so now in this example now, we are given with this all quantities. Okay, so this is called processed data. Okay, so we have now processed data. So we may have the raw data as x and y given, and we may have this processed data as directly given. So here processed data is given, and you can see now. I hope this answers your question. You can see the summation small x is not equal to 0, even though summation y is not equal to 0. So this is the processed data. But in process data, the mean is not taken exactly. Okay, so when this sum is not equal to 0, that means this mean is not taken exactly So this is the assumed mean. Okay, mean is assumed and then the data is processed. Okay, and now if this happens, that the mean is assumed and then the data is processed, then we have to find out the value of R. So if you remember the first formula that I have given to you. Okay, see the first formula. So what we can have the solution for this problem. So we have solution. Let now we don't have to process the data, so that's why we write the data what is given to us. So n is given to be 20. Directly we can have summation small x is equal to 100, summation small y is equal to 75, summation x square is 625, summation y square is going to be 610, and what is given to you, summation x into y is equal to 496. Okay, so this is the given data. Okay, it is already processed. Okay, and then what we have to write is, then we can say the coefficient of correlation. The coefficient of correlation between x and y. The coefficient of correlation R between x and y is given as. Okay, so if you remember the formula was given to be, see, n times summation xy minus summation x into summation y, okay, square root of n times summation x square minus summation x bracket square, and here we have n times summation y square minus summation y its square. Okay, so please check this formula if you remember. Okay, then we have seen this formula. Okay, so okay, uh, have you got the formula? In the first lecture only I have given this formula, then I modified this. Yes, okay, so uh, the formula, check whether the formula is correct or not. If there is anything, we can rectify. Okay, so we got the formula now, and here you can see all the terms are known to us. So we know summation x, we know summation y, we know x square, we know y square, we know summation xy, and then we know the value of n also. So using this, let us write the terms and let us calculate this. So what we can have, 10 times. Okay, so what is the summation xy? Summation xy is we have 496 minus summation x. Okay, so summation x is 100 here. Summation y is 75, and then we have square root of 10 times summation x square 625 minus 100 square. Then here we have again square root. Sorry, this n is going to be 20. We have to be careful. So n is going to be 20 here. So this is 20 times. Then this is 20 times summation y square 610 minus summation y square. So 75 square. Okay. So we got this term. Now use the calculator and let us calculate. So uh, calculate this value and tell me what is the value you are getting for this. So we have R is equal to, and hence R is equal to. What about others? What is the sum you got? So what is the value of R you are getting now? So use your calculator and calculate. Rusa got one answer. Let us verify it. It cannot be negative. We don't have minus sign in the numerator. So numerator is the only quantity which will decide the sign of R. So we don't have a negative sign in the numerator, so it cannot be negative. So are you getting a negative numerator? Because most of the students are getting positive. So that is you have to consider. Okay. Nabil, you check your calculations where whether you have committed any error because most of the students are getting positive and that is going to be yeah, yeah, no problem, it's okay. It's okay, that's not a problem. Okay. So we have 0.5968. Okay, so we can say the answer you got is this is what you have here, so it is going to be 0.5968. So you got here, this is going to be 0.5968. Okay, so that is the coefficient of correlation. So is the coefficient of correlation between capital X and capital Y. See, this small x and small y are the processed variables. Okay, so it is given in the where x and y are the deviations from actual means xy. Okay, so find the value of r. So it is going to be this value r. So we have to find the r for capital X and capital Y always. Okay, so we have to be careful that this is going to be the coefficient of correlation between X and Y. Now, as I told you, so I hope most of you might have got this answer. So, is there anyone who got the answer other than this? So, is there anyone who got answer other than this? Or you are getting all the same? All of you got the same answer? Yeah. Yes, yes. We can definitely see this formula once again. Okay. Okay. So the formula. This is the formula that I have given you the first lecture. Okay. Then I modified it that as we know, if I am going to use the mean, actual mean, then this term will be zero. Okay. So this term is zero. This term is zero. This term is zero. This term is zero. So I will write it once again and I'll show you how it reduces. Okay. So what we have is we have R is equal to n times summation xy minus summation x into summation y upon what is the formula we have n times summation x square minus summation x bracket square and here we have square root of n times summation y square minus summation y its square. Okay, So now if I have x is equal to xi minus x bar, okay, so these are going to be the capital ones. Okay, so if I consider xi minus x bar, okay, then we can say this summation x is going to be 0. Similarly, summation y is going to be 0. So what will happen? This term will turn out 0. This term is 0. This term is 0. This term is 0. So what remains here is n times. Okay, so this will be n times summation x into y. X into y, and what remains in the denominator is root of n into summation x square, and here it remains root of n into summation y square. So what I can do is I have n times summation x into y, and this I'll be having root n root of summation x square, root n root of summation y square. Okay, now what happens here? So this n summation x into y, this root n and this root n will become root of n square, so it will become n. And here it remains summation x square, here it remains root of summation y square. This n will get cancelled and you will be having summation xy root of summation x square and root of summation y square. So later on I modified this formula to be summation xy upon root of summation x square and root of summation y square. And this is what you can see we have used in the previous example. So you can see this is what I have used. This is the formula, because we know this sum is going to be 0. Okay, we are using the actual means, so that's why the sum is going to be 0, and hence this formula is same as this formula if we consider x and small y be the actual mean deviations. Okay, so if they are going to be the actual mean deviations, then we are getting it 0. So I hope you got your query, Gaurav. Yeah, right, good. Yeah, so now we will see some example based on processed data with the assumed mean. Okay, so now we have to see the examples on processed data with assumed mean. That means the actual mean is not taken, but the mean is taken. Assumed, it is assumed to be the mean, and then solved. Okay. So before that, we need to understand one remark. Okay. So please write this remark. So it will help you to solve the next problems. Okay. So we have here. See, write down this remark. So let x bar. This is the actual mean A, which is the assumed mean. Okay. So A is the assumed mean, and then you can have the deviation from this assumed mean. This small x is the deviation from the assumed mean. Okay, it is not the actual mean deviation, it is the assumed mean deviation. Okay, so we have to understand these relations. So let x bar is equal to a plus summation x upon n, where x is x minus a. So you can see I have defined in the earlier cases x is equal to x minus x bar. So that was the actual mean deviation. But here we are assuming the assumed mean deviation. So it is assumed mean deviation, and then we can replace where a is obtained by replacing the actual mean. So actual mean is not used, assumed mean is used. Then we can have x bar is equal to summation x upon n to any integer. This is called as assumed mean. Similarly, we can go for y bar, and that's going to be p plus summation y upon n, where y is equal to y minus y bar. and B is obtained by replacing the actual mean. So we get y bar is equal to this to any integer, and this is going to be the assumed mean we assume. Okay. So you can see this is a capital Y. This is not a small y. This is a capital Y. This is capital X. Okay, and then we have to use this formulae to solve the next questions. Okay, so I hope all of you have written this remark. So have you written this remark? Yeah, please write this remark. Yeah, that will be useful for us. Okay, so then only we will able to solve the next problems. So please tell me once you are done, then we'll go for the next example. So are you done? If you are done, then tell me. So we can go for the next example. It should not take more time. Are you done? So if you are done, then please tell me so we can go for the example. Yeah, that's good. So you are done. Let's go for the example. So let us see the next example. Okay. Yeah. So you can see we have the given data now. So these are this remark I am going to use. Okay. So see here, calculate the correlation coefficient between x and y from the following data. So it is given that this n is equal to 8, summation x is equal to 120, summation y is equal to 136, and then we are given with this. Okay, so you can see what will be the mean. You can see the mean here. You can calculate the mean from here, and this is the assumed mean A. Okay, this is going to be the assume this 13 is going to be the assumed mean B. Okay, so this is the value of B, this is the value of A. Okay, and you can calculate x bar and y bar from here. So once you calculate x bar and y bar, you are able to calculate this summation small x, and then you are able to calculate summation small y. So when you have small x and small y, this is exactly the summation small x into small y. Okay, and this is the summation small x square. This is the summation small y square. And now, once you know the summation small x, then you are able to use the previous formula, and then you are able to get the r, the value of r. So here we have to be first we have to find out what is small x, summation small x, and summation small y, and then only we are able to find the coefficient of correlation. So here you can see the summation of small x will not be 0 and summation of small y will not be 0, because here the actual mean is not used. So here the assumed mean is used, and that's why the sum will not be summation x will not be 0 in this case. If it is actual mean used, then only the sum is going to be 0. Okay, so let us try this problem. Let us try to solve this problem. So we go with the solution. So let always write the given data. So n is equal to 8. Summation capital X is equal to 120. Summation capital Y is equal to 136. And what we have, see, A is equal to 12, B is equal to 13. So we have here, what is X will be having, small x is equal to capital X minus A, and that is capital X minus 12. Okay, small y is equal to capital Y minus B. So it is uh, capital Y minus 13. Okay, and hence what is given to you? It's given summation capital X minus 12 bracket square is equal to 160. So it is actually small x square. Then we have summation capital Y minus 13 square is equal to 201. So this is actually summation y square. Okay, and then this term. So what we have here, so this term is summation capital X minus 12 into capital Y minus 13. So it is going to be 50. So it is summation small x into y. Okay. Now we have. So what will be having? X bar is equal to a plus summation x upon n. Okay. And capital Y bar is equal to b plus summation y upon n. So what we know is okay. We again have the formula. So this is the assumed mean formula we have. But what we know is summation x bar is equal to summation capital X upon n. So this is going to be a plus summation small x upon n. Okay. And this y bar is what? Summation capital Y upon n. So this is b plus summation small y upon n. So why we are able to write this? Since we know x bar is equal to summation x upon n, and we know y bar is equal to summation y upon n. So using this formula, we are able to write this and now put up the values. Okay, so what we have here, see, this is 120. So we get here, this is 120 by 8 is equal to a, we know the value of a is going to be 12 plus summation x, and here n is 12. And we have summation y. So this is 136 by n. So n is given 8. So this is 13 plus summation y upon 8. Okay. So that's what we have. Okay. Now let us simplify this. Okay. So how we are able to simplify this? So I can multiply this equation by 8 and this equation by 8 also. So I'll be having 120. This is 8 into 12 plus I'll be having summation x. Okay, and I'll be having 136 is equal to 8 into 13 plus summation y. Okay, so tell me what you'll be having. Summation x is equal to 120 minus 8 into 12. Okay, and summation y is equal to 136 minus 8 into 13. So please tell me the value. What is the summation x and what is the summation y? So I hope you are calculating with me. X is going to be 24 and summation x is 24 and summation y is 22. Okay. So got this 24 and 32. Okay. So we got this is 24 and this is 32. Now you can see, as this is the assumed mean deviation, it is not 0. This is also assumed mean deviation, so it is not equal to 0. And that's what you can have. Okay, so I got the value of summation x. Okay, I got the value of summation x. I got the value of summation y. Okay, and we already know the value of summation xy, summation y square, summation x square, and so we are able to find the value of coefficient of correlation. So we can say hence the coefficient of correlation, the coefficient of correlation are between x and y. Okay, is given as, so r is equal to, what is that? You will be having n times summation xy minus summation x into summation y upon square root of n times summation x square minus summation x bracket square into square root of n times summation y square minus summation y square. Okay, so put up these values. So this is equal to 8 summation x into y. So what is summation x into y? It's going to be 50. So here we have, this is 50 minus. So what you have here? It is going to be 24 into 32. Okay, on. What do you have? Square root of 8 times. It is going to be summation x square. So what is the summation x square? It is 160. Okay. So summation x square. So it is going to be 160. So it is going to be 160 minus. So it is 24 square. Then we have here 8 times. So this is 201 and minus 32 square. Okay. So this is the value of r. So you calculate and then tell me what is value you are getting. So what is the value of r you are getting? What about the others? Please calculate. I hope you are calculating with me. Yeah, Anushka, Akhilesh, Dipesh, and Mukul got the answer. So I'm Gaurav. Good. Okay, so I hope now you got the answer. Okay, that's great. Okay, so the answer is minus 0.5739. Okay, that's good. So we can have this is going to be minus 0.5739. Okay, so that's correct. Okay, and hence we write here R is equal to minus 0.5739. Okay, so this is the value of R. So is the coefficient of correlation between x and y. Okay, So this is how you are able to get the answer. So the only thing that we need to understand the assumed mean. Okay, and then if you have understanding of assumed mean, and that's why this remark plays an important role to solve this kind of problems. Okay, so when we have this is going to be the assumed mean, this B is going to be the assumed mean, then we can get it. Okay, so do you have any doubt in this example? So here we need to be careful that if this small x is about the exact mean deviation, then it will be always 0. So if it is about the assumed mean, if it is about the assumed deviation, then it will be 0. So that's why other examples I have considered to be the actual mean deviation. So if I consider actual mean deviation, this is going to be 0. Okay, so it is always better. So if you have calculator, use the actual mean. But if you find difficulty in using the actual mean, then you can use assumed mean. But then later it will increase your calculations here. That's it. Either you calculate in the table and made it easy, or otherwise then you calculate the table as it is, and then with assuming the mean, and then calculate this calculation or calculate the R using this formula. Okay, so that's what we have. So I hope. Do you have any doubt in this example? That's great. The only thing is that the remark we have to take into account, and then using the remark we are able to get it.
Bendi.
Yeah. So that's what we have.